This is the video for Skillbuilder number 11 for trigonometry. We're going to start out with SOHCAHTOA, so S-O-H-C-A-H-T-O-A, and we're going to write out each triangle trigonometry equation to help us solve for the triangles below. So the first one, sine, we just look up here, S-O-H, so sine is opposite over hypotenuse. Then we look at cosine, that's the second part, C-A-H, so cosine is adjacent over hypotenuse. And then tangent is going to be opposite over adjacent. We can use these when we solve, like for these examples in example 1A and B. So if we look at A, we have to look from this angle right here. So from this 32-degree angle, we're looking at what sides we're actually working with. The legs always represent your opposite and your adjacent, and then your hypotenuse is always directly across from your 90-degree angle. So here we're looking at the closest leg, the touching leg. This is the adjacent. And then we're looking at the hypotenuse. So if we go up to our ratios again, adjacent and hypotenuse would be cosine. So we're going to do cosine of 32 degrees equals adjacent, which is x, over hypotenuse, which is 21. Then we're just going to use algebra skills to solve for this. So multiply both sides by what you have in your denominator. Those will cancel nicely, and we'll have 21 times the cosine of 32 equals x. Okay, when we plug this into the calculator, we're going to have 21 times cosine 32. So we get 17.81. And that's how you solve for a side. For part B, you're actually solving for an angle this time, but you can still use the same ratios when you do it. So if we're looking at this angle up here, we've got both of the legs, so we know we're dealing with opposite and adjacent. The leg across from the x is the opposite, and the one touching, just like before, is the adjacent. So if we're looking at opposite and adjacent, we should be looking at tangent. So tangent of x, that's what we're trying to find, is opposite, which is 7, over adjacent, which is 5. Okay, so for this, since we're solving for an angle, we're going to have to use the inverse. It's written as tangent, and it looks like a -1 exponent, but it's actually pronounced as inverse tangent of 7 over 5. And that's how we plug it into the calculator. So second, and then we hit the tangent button, and it should pull it up like this, and then 7 divided by 5, and hit enter. So that angle is 54.46 degrees. And that's how you solve for an angle using those. Okay. Now we're looking at the special right triangles, the 45, 45, 90 and the 30, 60, 90. Both have some unique rules for the side lengths that we can use, some nice shortcuts. When we're looking at a 45, 45, 90 degree triangle, the legs are always the same length. So if this one is n, then this one is also n. And the special rule for the hypotenuse is n times the square root of 2. Okay, and then for the 30, 60, 90 triangles, we have the same kinds of rules, but they're a little bit different. So if this is your shorter leg over here, always across from your 30-degree angle, then your longer leg is going to be n times the square root of 3. That's always across from the 60-degree angle. And your hypotenuse is going to be 2 times n, or 2 times that shorter leg. Okay. Now if we use that, when we do these examples right here, so I'll just kind of keep these here, and we can use those rules to solve. For example 2, the first one we're looking at a 45, 45, 90 triangle right here. We know that because the legs are the same length, so these angles have to be the same. So this is a 45, 45, 90. This has to be the same as this, and then this is always this leg length times the square root of 2. Okay, so this right here is actually n times the square root of 2, which means that n is 4. In this case, we're talking about x, so x is equal to 4. Okay, same idea if we go over here, except now our triangle is rotated. So here, this looks like this is the n times the square root of 3 side. Okay, so then our n is going to equal 5. Well, n is just x in this case. They just used a different variable. So then our x is going to equal 5. Okay, and then example 3, the last example down here, we're going to use the law of sines by solving for x in the triangle right here. Okay, so the law of sines is where you're doing the sine of the angle over the length of the opposite side equals the sine of an angle over the length of the opposite side. So in this case, we're going to use the sine of 62, and that's going to go over the opposite side length, so over 20, equals, and then sine of 85 over, that one goes with this one. Okay, so we have a proportion. We can cross multiply now. So we'll have x times the sine of 62 equals 20 times the sine of 85. Okay, if we're solving for x, we can just divide both sides by the sine of 62. They end up canceling over here, and we're left with x equals 20 times the sine of 85 over the sine of 62. When we plug that into our calculator, we'll get 20 times sine of 85, and I hit enter here, and then I'm going to divide that by the sine of 62. So I should get 22.57. And that's it.